Quick review, section 1.2 and 1.3, functions and their graphs. Objectives are, students will be able to evaluate using functional notation. Students will be able to determine the domain and the range from a graph. And students will be able to determine if the graph represents a function by applying the vertical line test. Let's go and get started. Alright, so let's look at what is a function. Okay, so if we look at these examples, actually this is an example of a function and this one's not. This one is an example of a function because if you look at the two sets, this is the set of A, set B, 1 corresponds to the 2, 2 corresponds to the 4, that's what these arrows mean, the 3 corresponds to the 10, the 4 corresponds to the 10, and the 5 corresponds to the 2. If it's a function, then for every element in set B, there's a unique element in set A. However, if we look at this side here, if we look at this element in X and then 0 and 4, there are two elements in set Y that go to the same element in set X. So shorthand is if you see a set and the domain values, that's these values, there are two arrows coming from an element, it's not a function. So that's why this one's a function, this one's not. Functional notation, if you'd like to pause the slide and kind of read through it, I'm going to go ahead and skip it. We're going to go through now how to read domain and range from a graph. So if we're given a graph, the idea that I'm going to use is you want to fence in this function. You want to think of being able to draw a rectangle and contain this graph. So if we look at this first one, y equals absolute value of x is a v-shaped curve, we want to see if we can draw a rectangle that contains the entire curve. So if we look at this rectangle, you can see the biggest it's going to have to get is just that big. We don't have to go any bigger. So we fenced it in. Once we've done that, then by looking at the left and the right, that's going to give us our domain values. The bottom and the top, that's going to give us our range values. So this is -6 to 6, that would be our domain. 0 to 6 would be our range. A couple more examples to give you an idea. So if you look at this function, and I'm going to draw arrows because technically this function continues infinitely. So it keeps growing and growing and growing and growing. So same idea. We're going to try to fence this function in if it's possible. Sometimes you can fence it in on the left and the right, sometimes only the top, sometimes the bottom, and other times, like this example, you cannot fence it in. It just grows and grows and grows and grows. So for this problem, this graph, you can see we would have to continually get our rectangle bigger and bigger and bigger and bigger, so we can't fence it in. So in this circumstance, our domain goes from -infinity to +infinity, -infinity to +infinity, and our range, bottommost to topmost, -infinity to +infinity. Let's look at the next one. So we have this parabola. It's facing downward. Here's a function. And we get the idea is then we fence this in. And again, let me draw arrows on the ends because this function continues infinitely downward. And we want to say, okay, well, can we fence this entire function in? Well, we should have an idea. Since it's going to keep growing down this way and this way, it's not going to be really possible, but it does have a maximum point there. So if we look at this graph, we can fence it in to a certain extent. We can find this topmost point, but everything else we can't. There is no finite point here or here or here. So in this case, the leftmost value is -infinity, that's over here. Rightmost is +infinity, that represents your domain. Bottommost is negative infinity, and the topmost is 15. So that's your range. Next, we're going to look at the vertical line test. So it's also called a pencil test. So we're going to take this vertical line and we're going to pass it through the function, the curve, and see, okay, well, how many times does it intersect? If it only passes through 1, then we know it's a function. So let's look at this first one. So we pass it back and forth, back and forth. You can see at every single point, it only passes through once. So this is a function. Look at the second one. Do the same thing. Pass it back and forth, pass it back and forth. You can see this one's not a function. There was a point here and here where it intersected in 2 points. So this was a yes, this is a no. Third one, pass that red line back and forth, and you can see everywhere it only intersects the curve at most once. So this one is a function. Let's continue. Oh, where's my cursor? There it is. Okay, so I'm going to let you take a second, pause the video, try to determine if this is a function or not, as well as these three. So I'm going to pause it, and then I'm going to write down the answers. Okay, so the answers are, for this one, it's a no. You can see it intersects in multiple points. This one's a yes, because if I draw multiple vertical lines, only once. This one's a no, and this one we did it one similar to just a second ago. So this one's a yes. Hopefully you got those right. Let's continue. Okay, so now let's look at evaluating functions. So one of our objectives was evaluating using function notation. Function notation, this is not f times y. Okay, this is f of y. That means we're taking our domain value and we're saying, okay, we're naming our function f. We're saying, okay, we're taking our function, we're plugging in this, and this is the rule. So let me show you what I mean. So for this first one, we're taking the y and replacing it with the 4. So wherever I see a y, I'm going to replace it with a 4. Right, equals 3 minus square root of 4, and then you simplify that. Okay, so we know square root of 4 is 2, 3 take away 2 is 1, and that's your answer. So we've evaluated using function notation. So you're already familiar with this from Algebra 1 and Pre-Algebra. We're just going up a few levels for Pre-Calc. Let's do the same thing here. We're taking the y value, our domain value is -1. So 3 take away square root of -1. And let's see if you guys remember, what is a square root of -1? We don't write it like this. Well, if you said a lowercase I, or the imaginary unit, or a complex number, you're right. Can't simplify anymore. That would be our answer. Let's look at this third one. Again, we want to replace the y with 4x squared. So I'm going to have 3 take away square root of 4x squared. Just like in the first one, square root of 4 is 2, and square root of x squared is x. So this would be 3 take away 2x. They're not like terms. You leave those alone, and there's your answer. Okay, let's continue. Okay, so let's practice figuring out the domain and the range from a graph. Again, we're trying to fence this function in, if it's possible. So you're trying to draw a rectangle or a square that completely encloses this function. So on this one, you can see there's no arrows. When you have arrows, that means it grows and grows and grows and grows and grows. This one has points. So I know I can fence this function in so it no longer escapes. And then I can go through, okay, well, my leftmost is -2, my rightmost is 3. Those are going to be my domain values. I'll just write a D next to it. My range is going up and down. Those are my output. So that's a -5 all the way up to 2. And those are my range values. Okay. In the next lesson, we'll actually look at using the interval notation to write that out. This is just an introduction. Let's try the next one. Same idea, we want to fence this function in, and you can see on this one we've got arrows. So whenever you see arrows, you know there's going to be an issue where we're not going to be able to fence in part of it, all of it, some of it. There's no arrows down here, so I know the bottommost point, and that's actually called a minimum, an absolute minimum, is going to be down here. So if I kind of draw this line here, so I know I can fence in the bottommost point. That's at negative 75. But this thing keeps growing and growing and growing and growing, sideways and up. So really there is no finite value for the left, right, or the top. So when there's no finite value, it's infinite. This would be negative infinity, positive infinity, and then positive infinity. And this is your going horizontal. This is your domain. Going vertical is your y or output. That's your range. Right. Hopefully you're getting the hang of it.